So I want to swap them both for something simpler. And when you look at what we're given here, it doesn't really look much simpler. It looks more complicated. But simpler means something that I could actually find the antiderivative of. If we're defining it that way, then yeah, this is simpler because I can actually use this. The other one I couldn't. All right? Same idea for this guy. So, this one, sine squared of x becomes 1 minus cosine of 2x over 2. All right, but in this case, it's x corresponding with x. Here, it would be 3x corresponding with 3x. All right, so slight adjustment that we have to make in order to make this situation play out, but not a crazy one. You want to see crazy? I know you don't, so I won't show you crazy. All right, so then your cosine function is normally cosine squared x would be 1 minus 2 cosine x. Cosine 2x. But it's not as simple as just being an x here. It's 3x. I'm going to pop in a little 3x here. It sure is. Paying attention. All right. So now, little housekeeping, a little bit. 1 minus cosine 6x over 2. And that's only because 2 times 3 is 6. Step down 36. So we successfully took a power of 2 and made it into an expression with power of 1. If this were the only expression within the integral, I'd be able to get the job done right here. Problem is, I got 2 of them. So in reality, what happened is if this got reduced to a power of 1 and that got reduced to a power of 2, power of 1 also, and combined together, we still have an order 2 situation. Right? It's still a power of 2, even though it doesn't have exponent of 2. If I were to FOIL this out, it's still going to have power of 2. I have to handle it. Right? So this ends up being kind of a double whammy, but it's good to get some experience with it, because then you won't be shocked when you see it on a test. It's number 7. So FOIL it out. The tops would factor to a difference of squares. Well, they are a difference of squares, just in factored form. So when you distribute them out, it'll become a difference of 2 perfect squares. 1 minus cosine squared of 6x over 4 dx. Now you could try to do another substitution. Now, I have a power of 2 here for cosine. So I could do the same process over again. Wrong one. But I don't want to do that. I want to use my knowledge of some pre-calculations, but also, I mean, even if you don't know them, they're on the previous page. This can be swapped out for another expression. What is 1 minus cosine squared equivalent to? Sine squared. So this is the sine squared of 6x dx. Which in turn, if I pull out that 4, I can make it as 1/4 times just the sine squared of 6x. The other way is fine too, and in fact, if you look at videos of past semesters, you'll see that sometimes I do it just working with the 1 minus cosine squared. But this, I think, is simpler, because now I can go directly to this relationship, replace the sine squared, the 1 minus cosine of 2 times dx over 2 dx. All right, whatever the sine function is of, in this case 6x. So we're looking at a quarter times 1 minus cosine of 12x over 2 dx. I could pull out the 2 again. 1/8 times the antiderivative of 1 minus cosine 12x dx. So 1/8, the antiderivative of 1 with respect to x is just x. Now, the second part, you could do u substitution there, but this is a good opportunity for baby u sub. All right, so secant squared might have been a little too tricky to see, because if you didn't know the antiderivative of secant squared was tangent, then it's over before it begins. But in this case, I know I have a minus sign, so let me carry down the minus sign. So I'm going to just focus on cosine of 12x. The antiderivative of cosine is what? Sine. If my integrand has a 12x in it, my antiderivative is going to have a 12x in it. That's how a chain rule works. And then start the process of checking it. We would say, okay, what is the derivative of sine of 12x? Cosine of 12x times what? 12. So if I take the derivative of this, I'm going to have an extra 12 floating around that I don't want. So I correct for it. Pop a 1/12 in front. Close this up, pop a plus c on it. And that would be our antiderivative. All right, that's assuming that you weren't interested in doing the u substitution for just this part. And it's up to you. You can do the u substitution, like u equals 12x, and carry out the process. But if you can see this, it is definitely a time saver. Definitely worth taking your time to really think about. All right, so I'm going to put a star on number 4, which is actually a slightly easier version. Actually, it's significantly easier than number 3. So in this case, I did the hard one with you, and I left the easy one for you. Quote-unquote easy one, because none of this is really easy. All right.